my name is Kimberly, and today I'll be walking you through how to use relay transformations for data manipulation as well as scaling your deployments. So at a high level, relay transforms allows us to manipulate data as it passes through the relay component. So this takes pressure off of the center and allows us to do things like suppress fields, rename, retype values, create new fields, or format data. Now, you may be familiar with the concept of relay routes, which directs data to different centers. Relay transforms sits between this redirection and data ingestion. So when you're consuming data from feed handlers such as the Kafka, Solace, AMS feed handlers, or through AMI client, you can use relay transforms to manipulate the data. So the configuration lives in two files, relay.transforms and relay.dictionary, which we'll get into now. The relay.transforms file defines when you want to apply relay transforms. So this is a series of line-delimited rules, and each rule has 8 different parameters that are delimited by semicolons. So the first parameter is just your name of the rule, and then you have priority. This is similar to trigger priority, where the lowest number will execute first, and then any ties are broken alphabetically. Then you define which tables that you want to apply that rule on. You have the name of the dictionary next that is applied by that rule. And then you have the expression to evaluate on the incoming row. So if this evaluates the true, that means apply the transformation. Then you have options. So right now we only allow either blank or the pass-through option, which I'll explain more later. And then the final 2 parameters are the action to take if the expression is evaluated to true or false. So you can either continue by leaving it blank or break, which will stop evaluating rules. Now, for each rule that evaluates true, a corresponding message will be sent into the center. So it is possible for you to evaluate true on multiple rules and send multiple messages, or send no messages at all. For both of these configuration files, there are a series of dev strategies that I think are helpful to keep in mind. So we'll go through some of those for relay.transforms. And the first one is using the pass-through option to ensure that unmapped fields get sent. So take this fixed message that we have here and a simple 3-field filter, and then these 2 rules that just differ by whether they specify the pass-through option or not. For the first rule, the message that will get inserted into the database only has the 3 columns that we defined here, whereas for the second rule, it'll pass through any column that wasn't unmapped, and you'll see that those retain the original numeric column names. Next is using the object types parameter to filter rule evaluation by table. So this is that third parameter I mentioned earlier, and the format of this is a comma-delimited string of which tables you want to apply this to. So for this rule, if we have data coming in on 2 different tables called feed 1 and feed 2, this rule will apply to all of the messages in those tables. Now, you can also map your messages to a different table name. So you would do this in the form target equals source. And in this example, say we have messages coming in from 2 different Kafka topics called htfix and ltfix. But in my database, I want the tables to match a certain naming convention, so I'm going to map them to different table names. And then finally, you can also use this kind of mapping to redirect data. So in this third rule, we have data coming in on the allFix table, but we're sending it to 2 different tables depending on the message type expression that we have there. So new orders with message type D are going to go to the new orders table. Cancel orders will go to the cancel orders table. And you'll notice that this is essentially a projection trigger equivalent. Now, you can prevent duplicate messages and manage your message flow by using the expression parameter and the break and continue cases. So given the series of messages here, with the first rule, what we're doing is we're taking anything that's coming in on the orders messages table, and that will have message type D. And then for anything that comes in with message type 8, we're trying to do 2 things with it. So first, we're going to send this and redirect it to the order statuses table. But for anything that is specifically a reject message or has exec type 8, we also want to send another message into a rejected orders table. So basically, this will allow us to see all of our execution reports, but also be able to query from a table that only has anything that was rejected. Now, remember how I mentioned earlier that if the incoming message evaluates the true on a specific rule, that'll forward a message to the database. So if you are applying relay transforms to just a subset of your tables, and there's some other tables that you aren't interested in transforming, it's important to make sure that you include a pass-through rule so that all of those non-transformed tables, the messages will hit this last rule and still get sent into the database, or else they'll just get dropped within the relay and never sent to the center. Now, let's shift to the relay dictionary file, which defines how data should be transformed. So this file will just basically define a bunch of dictionaries following this format. And there are two main actions that a dictionary can really do. And the first is catching incoming values and assigning outgoing values. So all of the dictionaries will have a name, and then within the braces, you'll define all of your logic. And usually the logic will follow the format of these four different types of statements. So let's look at a few examples to understand how these work. First is suppressing fields. So if you only catch a field or a column, but don't reassign it, it's essentially going to get dropped from the message. So with this dictionary, an incoming message with the extra info column, once it gets sent to the database, you won't see that extra info field. Now, if you wanted to rename a column name, you would do it like so. These two rules are essentially renaming the same way, where they take the lowercase exec broker that came in on a message and they rename it to a capitalized exec broker. The difference here is that for outgoing values, they're going to take on the type of whatever's returned from the right side of the operator. So let's say exec broker comes in as an int. With the second rule, it's just going to get inserted into the database as an int. But with the first rule, you're explicitly casting it to a string. So this lets you manage how you want your data to be formatted within the database. So a powerful part of relay transforms is that you can use center methods in your dictionary logic. So let's say we have an incoming column called publish, which is just the Unix epoch time of when that message is published from the source. And we can include a readable timestamp string by using the format date method to create a published string column. Now we just keep in mind that in order to have the published column still included in the outgoing message, you have to reassign it in the third line. And then we do the same for received and received string. We're just adding a new set of columns to define when the relay itself received the message, just to say if we want to check potential latency between the publisher and AMI. Now, when you're writing the received string column, you may be tempted to reference the received column that was created earlier, but this actually won't work. So dictionaries evaluate only on the incoming message, not like a partial transformation within the dictionary. So you want to make sure that when you're assigning outgoing values, you're only referencing columns that were included on the source message or standalone operations. Now, for dev strategies for the dictionary file, the first one is that dictionaries can extend one another. So in this example, we have the standard fixed dictionary, which defines several fields that are usually included in all types of fixed messages. And then we have the new order dictionary, which extends standard fixed. So if something comes in and the relay transform rule uses new order to evaluate it, it's going to include all of these along with the four order fields. And then this kind of extension also supports multiple extensions. So you can do A extends B comma C. One powerful thing for optimization is that relay transforms can be used to simplify complex trigger workflows. So here we have a set of 5 decorate triggers. This is actually from a client use case where their center architecture was getting pretty complex because they were building out a lot of different dashboards. So with this particular table F, they were decorating a lot of enriched values from separate reference tables. And we were able to offload this work from the center by converting it to a single relay transform rule and one trigger. So relay transforms will handle combining all of these source tables together, and then you only need one decorate trigger to enrich your final table. This also means that in the future, if you want to scale this workflow and add other tables to decorate from, you only need to edit each of these instead of adding more and more triggers. So another example is messages that get published as a JSON payload. In order to meaningfully analyze the data, you have to first parse out the individual columns in an AMI script trigger. Now, if you take this same block of logic and just convert it to a relay dictionary, this can now be done on the relay side. And then when data gets inserted into your center, it's already readable and markable. Another useful thing is that when you edit the relay dictionary or transforms files, AMI will automatically reload it even during runtime. And when that happens, you'll see in your logs 2 lines if the reload was successful. Otherwise, if there was an issue with any of the changes you've made, you'll see logs that will point out exactly what file and where the error was. Finally, you can turn on debug mode for relay transformations. So this allows you to see step-by-step message transformations for every message that comes in. So for every message, there will be a series of 3 log lines, which show you the message before it was transformed, after, and then how many total messages were sent.